So welcome. We're going to talk about Typescript.net, very, 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 very early stage for game modding, but you can do whatever you want with it. My name is Andrea Gaita. I am the editor tools tech lead at GitHub, and formerly I was at Unity and Novell and Xamarin doing mono stuff. So it's been 5 years since I've been here, so this is fun, FOSDEM. Okay, so let's get started. I have a lot of content, and I'm hoping to get through all of it, so it's fun for you. Languages and game development. Games are like all other software built on tech stacks, on layers. You usually have, for most software, one language, maybe two or maybe three. You might have some shell scripts for your build system. You use one language to do your app. You might have some data languages, formatting like, whatever, JSON, other languages that are accessory, but you do it all on one language. Games are slightly different because of the way of the disciplines that building games brings in. The game engine is usually on languages that have facilities for aligning data in memory, so that you can optimize putting pixels on the screen, basically. Not that these languages are better or worse than anything else. It's just like you can control how the memory is arranged, how the memory is layouted. You can send things to your graphics card at the fastest rate possible. So you pick those languages that are optimized for this. But you're making a game, and you're making it with... There's game engine programmers, but then there's the gameplay developers, and then there's the game designers, level designers, scene designers, the technical artists, everybody else building content on the game. They might have worked on the engine, they might not even own the engine. The engine is doing some things, and these people have to build content on top of it, which means the language that gets used in these scenarios is not necessarily the language of the game engine. You want to pick a language that is appropriate for the task that they're doing. Right? It's not about data alignment anymore in memory. It's not about the most performant and most fast. It's the one that's most expressive for describing what's happening in your game. And a lot of these people in these teams are not programmers at all. They don't come from a programming context. So they don't even know how to code. But they can code. They need tools that they can use to express what they're doing with the game without having a full CS degree. So in the game industry, this is very common. You have multiple languages building on top of each other to provide the best tool for each job, right? And while C and C++ is very often on the game engine, C#, Lua, Basic, Scheme, F#, all of these languages that are expressive or functional or data-oriented or have some other type of thing going for them is the language that everybody else is going to use to build the game with. Right? So there's the game. So I got interested in this topic back when I saw some slides from a talk from Naughty Dog about how they built Uncharted. If anyone has played Uncharted here, hopefully some. It's a game. It's a bunch of games. So Naughty Dog is a Lisp house. They're very, very heavy Lisp fans. And they really didn't want to give their designers C to script their game. It's not efficient. So, because Lisp fans, they built a variant of Lisp, a simple scheme language to give their designers, so that the designers could just focus on making the game, reacting to events, talking to the engine, but not touching the engine. There's all of these advantages to having a completely separate scripting language that's running in a VM in your game engine. Like the engineering team doesn't have to directly be involved. And when we talk about engineering, we're talking about people maintaining the engine. Doesn't have to be directly involved with the content creation for the game. Code is data. It's easy to just change what's going on without touching the game engine itself. The game engine becomes more generic. It empowers game creators, and side effect, it empowers modding communities. Because when you have a language that's completely separate, that you use to build your game on, you can give that language to someone else to build things on your game, because that's what you're doing. You're modding the engine. So it's just a side effect that it just becomes very easy to provide tools for modding communities to build their own content for the game. This is the example that they have for their language that they gave, and I was very curious about this, so I emailed the person that gave this talk, asking how do designers that have never coded before handle this? And it was like, they handle it just fine. They have no problems with this. They don't have a background in programming. So for them, this is just, it's easy. There's no side effects. They just react to things, trigger things, stop and play. Things happen, and they literally script the sequence of events that needs to happen whenever something else happens. They put things on screen, they attach scripts to things on screen, and for them, this is just, a lot of parentheses, but it's fine. They don't consider this programming. It's just scripting. So that was interesting. And sometime later, Neverwinter Nights, not that Neverwinter Nights came later, I had just looked at it later after Uncharted. Neverwinter Nights came out in 2000-something, and Neverwinter Nights is an RPG based on D&D 3rd edition, just usually multiplayer RPG, but it has one key difference. This is Neverwinter Nights. It is fully moddable, as a lot of games are, but back then, not a lot of them were. And it has a full editor shipped with the game. So now, this is available for the people that are running the game, not the people that are building the game. The people that build the game also use this to build the game. But this is shipped with the game. The thing with Neverwinter Nights is, when you're running the game, you can fire up the editor, create your whole campaign with all of the things that Neverwinter Nights ships, like all of the assets. They give you a license for all the assets as long as you're not making money with the assets. You have all of the assets, like all of the characters and all of the tiles for terrain, everything. You have all of these things. So you can create a completely empty space, and you can build your own campaign. Just put all the scenarios together in the editor, and then you can script everything. So you can basically go into any of these objects that are in that area, and you can attach scripts to them. And the script is a C-like language, basically, that they have, which allows you to make these things interactable. And then anything can interact with anything else, and anything can do anything, which means you can just basically, you have a game, and you just make a new game out of it at runtime. Let's just say this, right? You're not compiling the game. You're just building this content out of a shipped game. It also has like all of these things that you can edit. Because, if they have the tools, they had the scripting language, and they had all of these tools that they built to make their game, it's free for them to just give this to the users. There's no change. There's no overhead for them. There's no support that they need. It either works or it doesn't work. The interesting thing about Neverwinter Nights, and I'll get to TypeScript and IL at some point, this is background for why I'm doing this, is that not only can you do all of this scripting at runtime, but the admin that's running the game, while the game is running, because this is a multiplayer game, so you can invite your friends to go into your server and play with you. Unlike the same way that you play multiplayer, but this time you're hosting the server, you control who comes in and comes out, it's your game. The admin that's running the game can go into the game while it's running and take over an NPC while another player is interacting with that NPC. Just override the entire dialogue tree of that NPC and start interacting with the player directly. And it's the ghost in the machine, right? And they can make quests, like on the fly. Like, yeah, we're gonna make a quest for you right now because I'm bored and I'm gonna run a quest for you, but I'm an NPC. And this got me really interested because there's not a lot of games that do this. In fact, there's none. Neverwinter Nights is 20 years old. There's still people running Neverwinter Nights servers. Because, when you can do that, it's fun. it's a community, right? And we all know the popularity of Minecraft and other type of environments. It's about how you can modify the environment and interact with other people. This goes to a slightly next level, but it's an obvious next level. If you can control all the content and you're doing this at runtime, why not do it at runtime and control, literally override the system whenever you want? But Neverwinter Nights looks like, old. So, a few months ago, because of that, it was like, it would be so much fun. We could do like something like this with better graphics and nicer engine, right? And just not side effect, but it turns out that most D&D data, like all the monster descriptions and all the levels and all of these things, is open source. Wizards of the Coast open sourced D&D 3.5 and D&D 5.0. Not the names of the characters, like the named characters, the bosses that you fight, but every single other data set, from magic spells to names of creatures, like everything that you can find in a D&D book, all of it is under a license called OGL, Open Game License. So it's all open source. Anyone can take that content and make things, which is how, forgetting the name, what the company that builds out of that content is. There's a company that builds entire contents out of this because it's open. So it's like we have all this data, and we can make this, and then we have Unity, which is a game engine that runs on C# and Mono. So we already have a VM that is that can compile things at runtime and reload, because that's what it does. We have a game engine that runs on top of this VM, so we can put all of this together and recreate what Neverwinter Nights did with a modern engine, modern language, modern everything. So we come into scripting system. At this point, I'm still thinking I'm going to use C# for this because C# is there. I know C#. I worked on Mono. I know that part is easy. Doing a reloadable, recompilable system at runtime is easy. Loading all the data is hard. But then I had this problem, which is why Typescript. So I'm gonna show you the little silly prototype of the system running, so you can understand my problem. So this is a very silly prototype of a thing that moves around. That cube is a trigger right there, and this script is attached to it. This is the default content. It's not compiled as, but if I compile it, I've compiled the script. I've reloaded all the data. Now, if my thing goes there, like there's a bug. I don't know why it says activate instead of yay, but in any case, it now activates because the script is now attached. I recompiled the domain and did all this. This is cool. And I mean, it's nice. Like, it's a one-liner. I can just do it. Anyone can go in and write code. But, like, code is not one-liners. When you're writing games, it's never one-liner. It's, like, get this object and do some math on it and do something or other and update this state or react. It's multiple one-liners. It gets complicated. And the problem with C# is that the code that gets generated is actually this. Oh, and that's why it doesn't say logger. It didn't actually generate the right code. It's this. For that line to run, which should be in here, right? For that line to run, I have to have all of this scaffolding because C# requires it. This is what C# looks like, right? And now I have a new problem. If I just provide the users with an interface to type a one-liner, they can't do more than one-liner scripts. If I give them all of this, because they will actually need to define some helper methods or to pull in other things, and all of these facilities that the language actually has, they can break everything. They're very easy to shoot themselves in the foot, like method signatures become complicated, like what do I override? It's no longer the language that I give a designer so that they can quickly react to events, right? But if But if I go back and just give them, like hide all the scaffolding, I'll figure it out somehow. If you take all of the code that you're writing in the little editor, put it somewhere else in an IDE, it's not valid C# code. Valid C# code needs this. So I don't get code completion anywhere else. For code completion, I need all of it. I don't need, syntax highlighting, all of these facilities. That is the reason why we use C#, because we have all of these things. So C# is not the best language for this. And I looked at Lua and I looked at other languages, but I didn't want to. We have .NET, like Unity runs Mono and .NET. Like I have this. And then I looked at TypeScript. And it turns out it's perfect. Because TypeScript is a fully typed, it can look just like C# in a fully typed mode. There's all type information, but it's flexible enough that it doesn't require all the scaffolding. So when you copy paste the entire code into VS Code, you'll get the type completion. And the language actually allows you to just go you know what, ignore type completion, but don't give me errors because I don't know what this thing looks like. Because it's JavaScript in the bottom. Types in TypeScript are a superset of what the thing actually is. And so it's flexible enough to be used for people, anyone. There's a lot of resources online for people to use it. It is typed enough for me to take it and throw it in IL because I have all the types that I need to do this. So then it comes to the things that then people, these are the things that designers and people that are making code need to do. Like integrated VM check. Like all of these things both C# and TypeScript can do, but defining types is the thing, right? In C# when you define types, you have to know what you're defining. You define classes and structs, and there's a logic. And if you don't define them up front, nothing will work or compile until you do. There's no flexibility in the type system at all. It's type first, and then script. And TypeScript, it's script first, and then type. You can go, trust me, it'll work at some point. It's fine. Which is, I mean, if the type is not defined at some point, it's not fine. But the IDEs will work. The IDEs will be very flexible about people not knowing exactly what they're doing up until the point where you run it. But at least when you're prototyping and building, the IDE is not getting in your way. It's helping you. And it's helping you learn, because if you type one thing, it goes oh, I've seen this before. Sure, I'll help you again, even though it doesn't exist. But I trust you, it'll always exist. So I saw all these things and thought, TypeScript. I'm going to skip all that. So these are the things that I ended up with for TypeScript. TypeScript is transpiler friendly. It's not a real language. It's a facade on top of another language. That means it comes with full tooling for IDEs, for figuring out what the code is, building ASTs, because that's what it does. And since we only have 10 minutes and I don't want to bore you more with talk, I'm going to leave you with the turtles, and I'm going to show you some code. So that was my, motivation for all of this stuff. So basically, actually, I have another slide that I can put up. So basically, what TypeScript gives you a TypeScript namespace, TS. That's the namespace for the ASTs, compilers, parsers, type checkers, and all of the stuff that's built into TypeScript. Like this is built in, you don't need to pull in anything else. To actually get any code to be parsed by TypeScript, literally this is what you need to do. You just do create source file, give it some name, throw in some code. You can read it off of disk, whatever. Throw it some code, and then tell it to transform. You implement a little visitor pattern that will get called for every node that the TypeScript finds. TypeScript will build this AST. For those 2 lines up there, this is what TypeScript automatically gives you. It will give you calls for every single one of these nodes. This is a little tree. Source file has all of these nodes, and then you can go down and you can decide whether to go down or not. I just recursively go down by doing that. Visit each child. This is the visitor implementation that I have. I go and I log what the node is, and I visit each child, and then this is what I get. And that's literally what you have. So you can see this is not valid TypeScript. Or is it? Does TypeScript actually care? Does the IDE actually care about this? It doesn't, because it actually thinks this is a property access expression. It doesn't say this is gibberish. It actually says, hey, this is an object that has a property, and there is another property. If you provide TypeScript with more context about what these objects are, TypeScript will give you better information about what they are, right? So TypeScript doesn't care. It will still think that this code, and it identifies the syntax, which is perfect, because now we can write a class library access for .NET that TypeScript has no idea what it is. It won't complain, and it will give us type information and all of these things. And then what we get is, in this case, this simple line that TypeScript has no knowledge of. If I compile it into IL, you can see the tree that it provided. I'm not sure if you can see that in the back, hopefully. Those are all the nodes that I parsed. And I generate IL. And now we have .NET. And the IL that I generate is literally this, which is the equivalent IL for the TypeScript. So, 5 lines of code, TypeScript compiler. It's a bit more than that, but it's a good start. It was a good proof of concept. And this is where I started from to proof of concept, like, is this viable? Does TypeScript have enough type information that I can take this and produce a viable IL from it? Turns out, yes, because JavaScript there's only 2 types, string and number. And the TypeScript, JavaScript model is literally containers of key value pairs. It's a dictionary. Every time you access a property, it's literally going in and look at table and see if that thing exists. If it does, it won't complain at you. So, putting TypeScript on top of JavaScript you can do, because you can just build on top of the very simple string and number model, which is what they do with types. Taking that to C# is literally just deciding it's transforming the syntax into IL. Taking TypeScript and .NET is transforming the syntax into IL, and then deciding what is useful from the environment. Like, TypeScript and JavaScript are not just a language, but they're also the ecosystem, right? JSON.parse and all of those methods that you just take for granted. They're not actually part of the language. They're part of the ecosystem that happens to come with the runtime that you're running in this case, V8, right? When you're running TypeScript in .NET, you're running in the .NET runtime. So you get the environment that .NET gives you, which is system console, system, all of these things, right? And now you just get to decide what TypeScript that it makes sense in this kind of environment. It is just like literal .NET calls directly into it, or do you do some node facades to make it look like the normal JavaScript that you would see, but under the hood you just call into .NET to do these things, which are helpful libraries that once built, they're there and you never see them. These are the questions that I'm considering now. And then handling any, when you have a type that is not a type, where TypeScript just goes like, me, whatever. How do you transform that into IL? Do you just do like JavaScript and just make a dictionary of key value pairs? Whenever you see property access to an any type, you just go and look up. You just create IL that goes look up into the dictionary. That's an option. You could use a DLR. That's another option for and use dynamic as you would in C#. So these are the questions that I have around TypeScript to .NET right now. And then for game-specific stuff, I have to actually pass data around, but that's for the game. So this was, like, this is a very last minute talk, so the code is not up yet. Well, it is up, but it's not ready for consumption. But ping me, email me, because I really want to start fleshing out this thing, because I need this for the game. So, you know, and if you're interested, ping me on Twitters or email me or whatever, and I'll see about putting the thing that I'm calling TSIL for now up in public. And we got, yeah, a few minutes for questions.
We're going to set up while you folks have questions.
Yes. Questions, please. Yes. Or not. What?
Many people will just come up with questions.
If they have them, yes.